Hello everyone, welcome to Infostonsystems channel. This is David. We are on Semiconductor series. This is the 7th episode. Previous episode, which was 6th episode, we talked about logic gates. So if you would like to gain better understanding of logic gates, please go ahead and watch 6th episode and watch this one. This is because this episode is a continuity of the previous one. This episode we're going to see the real-time example how and or not logic gate works behind the smartphones. So I'm going to give you the very best simple real-time example. Now let's talk about AND gate. We already know AND gate has two inputs A and B and one output. So the output will be 1 only when both inputs A and B are 1. If any input is 0, then output will be 0. So we already have seen that, right? So let's talk about the real-time example in smartphone. So you have a smartphone with you, right? So assume that you would like to switch off your phone. What steps you would follow? First step, your phone side manual power off button, you have to long press. Then the display will appear with the options power off or restart. Alright, so when you touch power off, then only the phone will be switched off. So to switch off your phone, there are two actions required. When the both actions meet, then only the phone will be switched off. So let's talk about AND gate logic here. When you click long press the side button, what exactly happens is the power management chip transistor will be activated. The transistor output will be 1. It will be given to processor. The processor will understand that user long press the power button. According to that, it will instruct the system to display the options like power off and restart. So now you have to touch the power off button on the screen. So when you're going to touch the power off button on the screen, what exactly happened? Your phone screen is made of capacitive screen. It has a lot of electrodes behind that, right? So whenever you touch, that capacitive changes will happen, right? There are gonna be change in the capacitive. Like wherever you touch, then why the changes happen? Because we already know that your finger is a conductive material. So you are full of water and sodium and iron. So you are positively charged conductor. We already talked about the human body, how that conducts electricity current in the 3rd episode on the topic of electron. It was a really interesting topic. I hope you watched it. So as I said, the human body carry the positive charge. So your finger is actually positively charged conductor. So when you touch the screen is a capacitive based screen, then it will generate the small amount of electric field. When you touch, that touch area will be disturbed. It will change the behavior. Okay, so now you're going to touch the power off button on the screen. So first step, system has to identify the spot where exactly you touched. So which technology they use? Very simple technology. They use graphical method, X and Y. We already have, we have been taught about that when we were in the school, right? So graph X means that horizontal line and Y means that a vertical line. So when you touch any word in the screen, you can easily identify the spot by coordinating with X and Y, right? Same like that, when you click the power off button on the screen, so the screen's chip transistor will be activated. It will coordinate X and Y and calculate the spots. First step, it has to calculate the spot. So once the spot is identified, then it will generate the signal based on the area you touched. Now you touched the power off button. So that transistor will generate the series of binaries. So for your better understanding, I'm going to give you that output will be 1. The transistor will activated, then it will be generated output of 1. That 1 will be the output signal 1 number will be given to processor. So the processor will be identified that user has touched the power off button. Based on that, it will shut down the processor and the phone will be turned off. When you press the long button, there is 1. When you touch power off button, there is 1. So when input is both are 1, so the output will be 1, the phone will be turned off. So the same way, side power button long press, same like that, the transistor will give output 1. When you are about to touch power off, you change the mind, you do not want to turn off your phone. If that is the case, what exactly you would do? Either you will press the back button or you will touch blank area randomly on the screen. So which means, like if you touch anywhere blank area on the screen, same manner it identifies the spot by coordinating X and Y, then the transistor will generate the binary of 0. So means there is no action. So same thing will be communicated to the processor will make no action, your phone again turn to home screen. So this is what one input is 1 but one input is 0, then no action in the AND gate. So that's why nothing is getting changed. So now let's talk about OR gate. So OR gate, assume that you would like to wake up your screen of your smartphone. What you would do, either you have to single press on the side power button or you will have to double tap. Most of the phones works in the double tap, right? When you double tap on the screen, again that also will wake up the phone. So first step, so you would like to wake up the phone. First step, what you do, you have to click the power button, just one press, means there is gonna be the transistor power chip will give the output of 1. But now display, you haven't touched the display, so the display output is 0. So here either one input is 1 or gate output gonna be 1. So still that the screen will be woke up, right? Now instead of you going to touch the power button, side power button, you're going to double tap the screen. So what exactly happened here is, so screen's input is 1 but power off input is 0, but still the system screen will be woke up. Same manner, that's what OR gate works. Either one input is 1, then the output will be 1. So no matter, like true input has to be necessary to be 1. So now let's talk about NOT gate. So NOT gate, like whenever you give input, whatever the input you give, the output will be opposite. If you give input 1, the output will be 0. If you give input 0 to NOT gate, the output will be 1. So let's see the real-time example of the smartphone. You are talking to someone over the phone. So your environmental makes some noise or some voice that you do not want the opposite person to listen. What you would do suddenly? Immediately you will put your phone on mute. So what exactly happens here? When you touch the mute button, the spot will be identified, the transistor will be activated, then it will generate the output 1. When the output will be 1, it will be given to the processor. The processor identify the user wants to mute the phone. That processor will communicate with the system and the hardware of the microphone. The microphone transistor will receive the signal 1. The transistor output will be 0 because we are talking about NOT gate logic. Then that your hardware microphone will be turned off. When you're going to unmute the phone, means that particular transistor's output will be 0. Then again it will be given to the processor. Then your smartphone microphone hardware will receive the signal 1. Then the microphone will be turned back on. So that's the way, when the input is 1, then microphone will be turned off, that output is 0. When you unmute, your input is actually 0, then your microphone will be turned on, that output is 1. So this is the better NOT gate example. So I have given you the very simple examples, but you may have come up with the questions, how the processor identify and it communicate with the system respectively by this to charging panel and a microphone panel, how the processor communicate with all the systems, all the departments of the systems. Very simple one is everything's what behind the high level programming. So the high level programming only follow the instruction and communicate with the processor, but high level programming cannot directly communicate with the processor, because processor machine will understand only zeros and ones. Then means that high level programming has to be converted to the machine language. So in the next episode we will dive deep into that, and it definitely will gain the better understanding like how exactly the high level programming language works behind the processors and transistors. Until then, stay tuned. Thank you.